we are going to use R to exemplify the concepts we just saw. In this class, everything you do must be reproducible. So, this is what you're going to do. Let me go to R. I'm going to create a new R script file. Because here are the options. I can even write my commands here in the so-called script file, or I can write my commands directly into the console. However, I can save the script file. Therefore, if I want to run the same commands again, all I have to do is open the script file that I saved. Either if you have a job in industry or if you have a job in academia, you always must be able to reproduce your results. So here's my script. All these commands are in the appendix of your note. So if you want to copy and paste and then run one by one as we read the notes, that'll be okay as well. So how does the R language work? The R language is written in the form of functions. So here is an overall layout of these functions. First, I'm going to type the name I'm trying to create. Then I am going to type equal, the name of the function that does what I'm trying to create. And then every function in R has arguments, so I'm going to choose the arguments of this function. Now I'm trying to exemplify what we just did in the first half of the notes. So I'm going to start by defining the probability model using two vectors. Vectors are just lists or arrays. As we mentioned, we need two lists, a list of outcomes and a list of probabilities. That's how we define a probability model. The command or the function that creates lists in R is C. So here's my command. The name of what I'm trying to create is outcome. That's the name of the vector. That's the name of the list that I'm trying to create. C is the function in R that creates lists or that creates vectors. What are the arguments of this function? This is a very simple function, so the arguments are just the entries of the vector. Basically, we're going to tell R, what do you want in this list? There are three types of things that can be in lists: numbers, variables, and strings. Strings are words. How does R know the difference? In my case here, all I want is a word H to represent heads. The way I tell that this is just a string, is just a name, not a variable, I put quotes around it. So that's what it means. Quotes around H means H is not a variable or a number, it's just a name, it's just a string. The same for T, which means tails. So I'm gonna go here, select, run. Okay? Now, if I type the name of what I created here, this is what I get, a description of the list that I created. I could also type here, let me type the number base later. You can also type it here, select and run, and it gives me the list again. Basically, I created an object, I gave it a name, and whenever I type it here or type and run here, it returns what this list is. Now I'm going to create another vector, so I'm going to use the same command C. C is the function that creates lists or vectors. The name of this vector is going to be probability, and what is inside these vectors? The number half and the number half, which are the probabilities in my model. So type that, then select and run. And you can also see them here. This is the objects that you created. This one has HT, this one has half and half. Now, I wanna flip a coin using R. The function that does that is called sample. Sample is a function that draws what I'm trying to do is mimic the random experiment here. Now I'm going to name the result of this draw result. Again, the function, remember, the R language is constructed in functions. The functions that draws is sample, and this function has 3 arguments. The first argument is, what am I sampling from? I'm going to sample from the vector outcome, meaning I'm going to sample from the vector from the list that has 2 possible outcomes, H and T. So this is where I'm sampling from. Size equals 1 means how many times am I going to sample? In my case, I'm going to sample only once. Basically, I'm going to flip a coin only once. The third argument is, I'm letting R know what are the probabilities of each outcome, and they must be in respective order. So the probability of drawing H is half, the probability of drawing T is half. So go ahead, copy and paste this command into the script, and run. Here's my result. You can see that I happen to have drawn a T. If you keep repeating this many times, it can change to an 8. You are flipping the coin. Here, change a T again. Now if you want to see the results here, you can just type the object you created, and here it is, T. That's the outcome of your draw. If you don't want to give a name for already created, you just want to do it, you can come here and sample. So it just shows you the outcome of the draw, but it doesn't save it with a name. This is the one I had done it before. So this outcome is not saved because I didn't give it a name. Also, notice that we did not have to define the vectors in advance. Instead of telling R what is the name of the vector of outcomes, I could have just typed here, hey, this is the vector of outcomes. So I'm typing directly here. That's the size, and that's the vector of probabilities. Or alternatively, if I don't tell R the probabilities, R automatically assumes that the probabilities are all the same. So if I omit the third argument, R is going to understand that it's the default argument and the default is the same. So here, I simplify my command. Well, look, this time I got an H. Keep drawing. What you're doing is you're flipping a coin, or you're pretending to flip a coin here, and you're going to keep getting different results. The probabilities are half and half.